Hi, everybody. Thanks for coming out so early in the morning. I have to say it's a daunting task to listen to several talks and then suddenly generate some intelligent commentary about it, so forgive me if this is a bit jumbled. But I greatly enjoyed all of the talks. I thought Harry gave a really interesting story of success in the terms of scientific breakthrough built on a series of failures in history, or initial failures in history. And I thought David and Jutta both gave us a really interesting unpacking of what failure means in science, right? It's not just one type of failure. There's, in fact, a broad typology of errors. There are many ways to fail, right? As Stuart said, many ways to be unhappy. And I think that's really critical for thinking about what kinds of failures are good, what kind of failures are bad, and how can we sort of push on making those good types of failures versus falling into the trap of making negative failures. So I just wanted to pose a few questions, some very general ones, and one or two aimed at education in general, since I come from science education and educational psychology. So one is kind of, when do you know as a scientist when it's time to keep going and when it's time to call it quits? So when have you made a bad type of failure, right? For example, the wishful thinking type of failure that David talked about. And how do you know when you've made a really productive failure, right? Something that science is going to learn from in the future. And me being a kind of social scientist, right? For instance, I've been given the advice that to be a good scholar means you have to be kind of stubborn, right? And develop a thick skin. And even though you get negative feedback from reviewers when you submit your papers, you have to still keep working on those ideas, right? But some failures are actual failures, right? And signify that it's time to maybe stop an area of research or change the way you're studying something. So how do we know as scientists and scholars as well, when it's time to keep going and when it's time to call it quits? And then the second question, again, which I think is related, is I think David talked really nicely about positive kinds of failures and negative kinds of failures, right? So how do scientists learn to avoid those bad types of failures? How do they know when they're a bad failure? And how do they learn to push on good kinds of failures and productive mistakes? We have a term in education called productive failure, which was put forth by Manu Kapoor, and it's this whole instructional method where kids are pushed to solve a really complex problem where they're going to fail. But in that failure, it prepares them to learn from later instruction, right? So it helps them activate prior knowledge and identify knowledge gaps and begin to think about what kind of are the features that are critical to look at before going on to then, for example, receive a lecture about a scientific concept. And those kinds of productive failures, right, are actually good for learning. So I'm interested in sort of identifying those kinds of productive failures. And then a third question is sort of what can we learn about education, or what can science education take away from these stories of scientific failure? So more broadly, I'm interested in what kind of message would you give to kids and teachers who are learning science and learning that there are many failures that occur in science. What can they learn about the process of how science is done? And what should they take away as a message of how to build on these failures? So, for example, in the past 20 years, there's been this big movement in science education away from what we call cookbook science, right, where you kind of give students an experiment to do a priori. You tell them exactly what steps to follow in doing the experiment. The result of the experiment is predetermined by the teacher in the textbook, right? And there's kind of a canned solution that students are supposed to determine, and this predetermined knowledge the teacher is essentially dispensing out to the students. And we've been moving away from cookbook science to more, right, authentic inquiry, right, where students are learning that the goal of science is actually to generate knowledge, not just to guess what the teacher wants you to learn or demonstrate what's in the textbook. Sorry, I'm going over time, so I will stop. Anyhow, so what can we learn about authentic inquiry and the process of dealing with failures from this history of science that you've talked about? Thank you.